Namaskar, my dear friends. There has been increasing demand of automotive cluster designs, and for that we need a lot of power supply designs techniques, right? So in that case, what is happening these days is we need to have miniaturized solution, that is very small solution for like multiple power supply output. Like we need to utilize processors or FPGAs or SoCs. SoCs is nothing but system on chips, right? So in that case, we need to have multiple power outputs. Let us say we need to have 5 volt or 3.3 volt or 2.5 volt or 1.8 volt or even 1 volt. So those core supplies voltage or auxiliary supplies voltage for FPGAs and all these things are required, right? And as you can see, we need to have automotive infotainment solutions where we need to have lot of complex processing requiring SoCs or like processors. Similar to that, we have industrial controls and power supplies. In that scenario also, we need to have low like voltage level but higher current rating. So this is the IC that we have chosen for our various solutions, LT8602, which is very nice, which is going to give you a quad monolithic step down regulator. Okay, so there are four outputs that is possible from this IC. Okay, so as you can see a little bit detail about this particular IC that is there from Analog Devices is LT8602, and this is the product page that we have given. So we will be giving you in the description box, and this is the datasheet link. Absolute maximum rating is there, that doesn't matter, but basically why I am giving you this understanding is you can see the input voltage it can take up to 42 volt. It means around like even 30 volt or 36 volt if you give as input, it is going to be able to give you output of 5 volt. Okay, so that's the beauty of this. As I have already explained you about the applications, so like automotive systems as well as distributed regulated power supplies and industrial control power supplies, so these are the places it can be utilized. Okay, so now let us directly get into the a circuit that we have designed. So this is the circuit that is there for my automotive cluster design using one of the SoC that we have used, that is there from Zinc 7000 series, and like lot of other processors also if you want you can utilize. Anyway, so what we are going to do now is we will try to understand how we are going to design the input voltage and output voltage based on this particular IC, which is LT8602. So let me first clarify you about the design requirement. So design requirement is there are four outputs: 5 volt 1.5 ampere, then 3.3 volt zero point 0.8 ampere, 1.8 volt 1.5 ampere, and 1.2 volt 1.8 amperes output. Okay, and as you can see we have the input voltage here which can take up to, let us say we are going to take up to 12 volt or like even 9 volt to 12 volt we can give it. It is capable of taking up to like around 30 volt also, but to have better efficiency and all these things, try to limit your input voltage up to around 12 volt or 15 volt. Okay, and nicely designed like capacitors, input capacitors, and then output voltage is made here. As you can see we have four outputs like at SW1, SW2, and SW3 and SW4. So there are four outputs that is there, and each of the output has one feedback setting pin that is going to give you an understanding of a voltage divider resistor which will help you to set the or regulated voltage output. Okay, so that's the understanding we should have. So we have nicely coming up as 5 volt here, then 3.3 volt, then 1.5 volt, 1.2 volt output. Okay, so hope you have now a very good understanding how we have done this thing, and at the same time you can see the two outputs that is there like 5 volt as well as 3.3 volt, that is coming from input voltage, main input voltage. Okay, and the other input voltage that is there The other input voltages that is there, which is 1.8 volt and 1.2 volt, that is actually coming from 3.3 volt input. So you can see 3.3 volt is used as input for PV3 and PV4. Okay, and each of the pin will be having one 10 microfarad and plus 0.1 microfarad capacitance. Okay, so that's the understanding you should have. If you want, you can have an extra, like one more 10 microfarad capacitor at these particular places. So instead of that, if you want, you can have 22 microfarad also for these two as a bulk capacitor. And these PG pins have been actually pulled up, so you don't need a controller. But if you want to check it, or like if you want to keep a monitoring of each of the output pin, so for each of the voltage regulated output, you have a separate power good pin, PG1, PG2, PG3 and PG4. So these four output pins will give you an understanding of that all the outputs are fine. Whenever they will go down, that is 0 or low, you will understand that your output is not good. Okay. All right. Let me quickly give you an understanding of the, like calculation that we have done. So this is the IC that is there, which is used, and this is the output voltage setting. So output voltage setting from the data sheet, if you come, you will be able to see this is the output that can be calculated. So what is the resistance R1 and R2 that will be there based on the output voltage that you want to set, and this is the feedback resistor value that is there. So feedback voltage is there corresponding to, like let us say my input voltage is 12 volt, output is 5 volt. So if you want to set, we are setting R2 as 113k and we are saying R1 as 452k. Okay. If you want to change, you can change it 110k, so it will become 440k. Similar to that, PV in 2 is 12 volt, PV in 3 is 3.3 I told you, and then PV in 4 3.3 volt. The, like this color is actually there, which is going to give you the output voltage 1, 2, 3 and 4. And their corresponding, like this equation is actually nicely calculated. So you can see the corresponding inductance has been calculated in front of this. Okay, so this is very nice. So if you want, you can refer this particular calculation sheet as well. So if you need to have a calculation sheet, you can always put down your comments in the comment box and we shall be able to give you or send you this particular calculation sheet as well. So hope you have now a pretty good understanding about this particular power supply that we have designed for your automotive infotainment solution, or like automotive cluster design for various outputs in a single IC. So if you have a design requirement, or like if you have some questions regarding this particular IC, you can put down your questions in the comment box and we shall be able to give you solutions as soon as possible. Thank you guys.